DNA replication is a process of producing two identical replicas of DNA from one original DNA molecule. The flow of information starts from DNA and RNA to protein. DNA undergoes a process called transcription, while mRNA undergoes a process called translation. There are three alternative models of DNA replication, which is conservative, semi-conservative, and dispersive. Semi-conservative replication of DNA with two strands of parental molecules separate to produce a new complementary strand. After the separation of two DNA strands, the old parental strand will act as template. They will produce new complementary strands and two identical DNA strands are formed.
Hi everyone, it's Lily. Now, I want to talk about enzymes and proteins in DNA replication. In this DNA replication, there are 5 enzymes and 1 protein are involved. So, what are the types of enzyme and protein and their function? Let's go and talk about it. First is helicase. And this is structure of helicase. And this is single strand binding protein, SSB protein. And this is structure of single strand binding protein, SSB protein. Third is topoisomerase. And this is structure of topoisomerase. Fourth is primase. This is structure of primase. Next is DNA polymerase 3. This is structure of DNA polymerase 3. Then DNA polymerase 1. Structure of DNA polymerase 1. Last is ligase. Structure of DNA ligase. Today, we have a very special guest to explain about formation of leading string. Please welcome Sherlock Holmes.
Hello everyone, I'm sorry but I'm not feeling so well today, so I asked my younger sister Enola to replace me. Don't you worry, she is intelligent as me and pretty. Enola, come in.
This is leading strand. This is the step of formation leading strand.
DNA that is going to be replicated. DNA is unwinding here thanks to helicase. In this example, it will keep unwinding in this direction. Primase places primers. DNA polymerase is building the new strands. Now, the thing about DNA polymerase is, when it's building a new strand, it can only build the new strand in the 5' to 3' direction, meaning it adds new bases to the 3' end on the new strand. See how it's being built in the 5' to 3' direction? This one is called the leading strand. But take a look down here. So DNA polymerase once again is building a new strand in the 5' to 3' direction. But there's a bit of a problem here. See, as DNA unwinds, because DNA polymerase can only build the new strand in the 5' to 3' direction, it has to keep racing up here next to where this unwinding is happening. You can see why then this new strand is known as the lagging strand. On this lagging strand, primers have to keep being placed in order for DNA polymerase to build. These fragments that